How many random people do you think are needed to get a 50% probability that two people have the same birthday? Assuming there are no twins, no leap year, and no patterns. The answer is not 50, 120, or 183 as we may guess. But the answer may seem surprisingly low because the answer is only 23 people to get the 50% probability that two people have the same birthday. This is what we call as birthday paradox. Okay, but how to get that? Hello, it's me Arya Syahputra. Let me explain it to you. So how birthday paradox can happen? This is where the math works. To calculate the probability that at least two people will have the same birthday, it is easier to calculate the odds that no one shares their birthday. Because the sum of these two probabilities is equal to 100%. It means the probability that at least two people have the same birthday is the difference from the odds separated from 100%. Let's start with person number 1. The person number 1 has 365 chance in a year for their birthday. So we write as 365 over 365. The odds will be 1, and the probability that two people have shared their birthday is equal to 0 or 0% because it's only 1%. Next to person number 2. The person number 2 we multiply by 364 over 365 because one day has been person number 1's birthday. So the odds is 0.9973 and the probability of two persons share their birthday is equal to 0.0027 or 0.27%. Bring in person number 3. We multiply by 363 over 365. So the odds is 0.9918 and the probability that two people share their birthday is equal to 0.0082 or 0.82%. Okay, we keep doing it until the 23%. So we get the probability that no one share their birthday is 0.4927 and the probability that two people have shared their birthday is equal to 0.4927 separated from 1 and the difference is equal to 0.5073 or 50.73%. This is what we called before, that in a small group with 23 people, there are 50.73% probability that two people have shared their birthday. We can simplify this complicated calculation to make a formula for n people. That is 365 factorial over the factorial of the difference of n separated from 365. Then the product is multiplied by 365 to the power of n, and the quotient is separated from 1. So we got the formula to get the probability that two people share their birthday. By this formula, we can make the graph for n people. By the graph, we see that the exponential grows. When there are only 2 or 3 people, the probability is not even 1%. But when there are 23 people, the probability is going up to 50%. The birthday paradox is not a paradox in the true sense of the word. It's more of an astonishing realization. Once people are presented with the proof, what makes it interesting is that our intuition is not just to exponential growth, because our brains tend to measure it linear.